Let us see on geometry now. So in the given figure given below, AB is 10 centimeter, BC is 10 centimeter. So you got to find what is AD, BE, and CF. Okay, so let us find it. So we have been given that AB, which is 10 centimeter, BC, which is 10 centimeter, and AC is 10 centimeter, right? And we got to find AD, BE, and CF. So we can see that the three sides of a triangle touch at uh, touch the circle, which is D, E, and F. Yeah. So let us begin with side AD. So let us assume AD as some X. Okay. So then then uh, then we have AF as X. Yeah, we have AF as also X. Okay, so we know that AB is 10. So therefore BD will be, that is AB is equal to uh, AD plus BD. Okay. Then BD will be 10 minus X. Okay. So similarly, what can we say about the length of CF? Yeah. So this is AC is equal to AF plus CF by segment addition property. Okay. So CF will be 10 minus X. Yeah. So let us consider BC. Yeah. The side BC of the triangle. The total length of BC is equal to the sum of BE and EC. So this will be BE plus EC. Yeah. Now let us substitute the values and see what happens. Yeah. So BC, which is 10, and this is 12, 10 minus X, plus 10 minus X. Okay. So this results to 2X is equal to 20 minus 10, or we can write X as 5. Okay. So we get the value of X. Okay. Now let us substitute the value in the given information and find the value of of that is BD, which is 10 minus X, which is 5, and CF, which is 10 minus X, which is 5 again. Therefore, we got the values as AD, which is 5 centimeters, PE, which is 5 centimeters, and CF as 5 centimeters. Okay. Now let us solve this problem. You have PQRS circumscribes a circle, then you have to find PD plus QB, right? Okay, so given is PQRS circumscribes a circle, so that is all the sides of a quadrilateral are tangent to the circle. Okay, so PD is equal to PA, and QB is equal to QA. So let us denote this as 1 and 2. So this is the lengths of the tangents drawn from an external point are equal. Okay. Now by adding 1 and 2, okay, so PD plus QB is equal to PA plus QA. By adding the equation, right, we get as PD plus QB is equal to PQ. Okay. Now let us solve this problem. Okay. So here AB is the tangent. Okay. So so that is drawn on the circle from point A, and so the radius OB will be perpendicular. The radius, you can see here, the radius OB is perpendicular to AB. Yeah? That is OB perpendicular to AB. Yeah, and we know that OA, which is 5 centimeter, and AB will be 4 centimeter, right? Now the in the triangle, which is ABO, yeah, OA square is equal to AB square plus BO square, right? Using Pythagoras theorem. So this is 5 square is equal to 4 square plus BO square, right? Or we get BO as 3. So the radius of the given circle, BO, which is 3 centimeters. Okay, let us solve this problem now. Now we know that the radius is perpendicular to the tangent, which is OR is perpendicular to PR. Okay, so that is angle ORP is 90 degrees. So likewise, we have OQ, which is perpendicular to PQ. So angle OQP is equal to 90 degrees. So in quadrilateral, ORPQ, okay, sum of all interior angles is 360 degrees. So angle ORP plus angle RPQ plus angle PQO plus angle OQOR is equal to 360 degrees. Yeah? So this is 90 degrees plus RPQ plus 90 degrees plus angle QOR is 360 degrees, right? And so angle O plus angle P is equal to 180. So QORP is a cyclic quadrilateral. Okay, is a cyclic quadrilateral.